Thanks everyone for coming. My name's Kevin Shackleton. Um, Joe had, after the Docker Tech Talk, which actually, how many people saw the Docker Tech Talk that we had at Innovations, or the recording of it? So a few people. Okay. So after I run our internal Tech Talk program, or the Tech Talk program where we have external speakers come out and have them at Innovations. And I've been following Docker for a bit over a year and just been tinkering with it myself, and brought Docker out to do the Tech Talk. And Joe was there, and afterwards he asked if we'd come out and do a Tech Talk here, continuous to talk about Docker. And so I agreed to that, and then I had been watching what Dan here has been doing within Cerner with Docker, and he's been doing much more than just tinkering, which is what I've been doing. So I asked Dan if he would come for this Tech Talk, and he thankfully said yes, because he's going to be able to provide a lot more information around what we're planning on the development side of doing long-term with Docker, as opposed to just me, which is just what I'm playing around with and having fun with. So I'll let Dan here introduce himself and take over.
Cool. Thanks, Kevin. Okay, so I'm calling this talk Docker Fundamental Change, mostly because if you the way you think about deploying apps and stuff could really change with Docker, and the way you can deploy an immutable state essentially that you run in dev, and you can go ahead and promote that into prod. There's a lot of documents out there that people talk about essentially running these like a VM or something, or running multiple processes, and that's probably not the best way to look at it for a final state anyway. So if we can get to a point where we treat Docker kind of the way that they think that they should be treated, where it's an image that you build in dev and then you run up through the chain to prod, then we can generate some real fundamental change in how we deploy apps and how they interact, and the types of systems that you can build with this type of thing. And what is Docker? It's definitely not a VM, so don't treat it like a VM. I do some stuff on my Docker containers to not corrupt my VMs, just playing around, but I would never deploy an app as if it were a VM. It's a layered file system, so it doesn't have its own kernel. It's really just a file system that is made up of different layers. So if you install something in one layer, it's there forever. You may not be able to see it in the final layer, but you carry the size around everywhere you go. So it's really important to, in fact, Docker talks about this in their docs, to make sure that you think hard about how many layers you have and what you put in each layer and what you remove from each layer. So Docker is also a containment area for a process, for one process generally. There aren't that many use cases for where you want to have multiple processes. If you have multiple processes, you should probably use multiple containers and connect them in some way. And it uses several different technologies to make this containment that I'll talk about later. It's mainly based on C groups and uses namespaces. I'll go into those a little bit more. And it will eventually use user spaces, which is not really active in RHEL. But that will allow mapping of users inside containers to users on the host system, so that you don't have root 0 in the container running as root 0 on the host, which helps some of the security issues. And it uses the host kernel.
Hey Dan, before you go on, tell me if this is on another slide, but what problem do you think you're trying to solve? Maybe that was slide 2 or slide.
Oh yeah. So why Docker?
Well, I'm even saying why anything, and then maybe why Docker is better.
So right now,
this kind of crosses some lines of some things we're seeing, like the DoD conversation right now and things like that. So what problem do you think what Cerner problem are you trying to solve?
so if you have, we find a lot of problems with things like Chef managing state. You can get where you have different versions of Java on the same machine running, different processes that you don't want actually running those processes. You want them all in Java 8 or something, and you have a Java 6 in there running, and you have issues that result from that kind of thing. This, you package up your Java and you send it on up the chain. So you can have, which I'll show later, a Java 8 and 7 running on the same system without any issues.
You want all the required resources for a given whatever process to be associated together and separated from the other regardless of the physical infrastructure. Is that fair?
Right, so it will be separated from the physical infrastructure or virtual machine. More importantly, that the processes are separated from one another.
That's what I'm saying. Both.
Right, that's the big concept. And Docker makes it easier than managing your C groups or something, which can be difficult. So I've already said that if you build it in dev, you can run it in prod, the exact image. And you can start up as many containers from one image as you want. There's a finer separation of resources per node. You can use C groups, or Docker uses C groups. You just specify the CPUs and memory. We've seen issues, especially in Jenkins, which is where I'm using Docker first, where our builds will crash other builds because they run out of memory on the host. This prevents that because you can never over provision your memory, and you'll be able to take your image and put it on really whatever you want. So you could run rel 6, which is what we use a lot of our stuff on, with a rel 7. So you can upgrade your host and just keep running a rel 6, or be really boring and run rel 6 on rel 6. You can also update your host that way without worrying about what might happen to your containers or something, because they're separated. The container does use the kernel though, so if you were doing some real low level stuff, you may see some issue going from rel 7 to rel 6. I don't know of any. I'm not a kernel guy, so I don't know what the issues might be, but that would definitely be an issue that could come up depending on what kind of features come out in the new kernel.
Your bullet number 2, is it more focused on security or provisioning of resources, both?
Both.
Okay.
Yeah, definitely both. It's really good to be able to separate resources, but it's also just that separation of the process from other processes.
And then before you go along, you go back 2 slides. One of the things that you put in there, container area for a process.
Yes.
Do you need one process or many processes? Because I've heard lots of things back and forth on it.
Right, so you could run a lot of processes if you wanted to. It's not the general practice. It's not a best practice. You should be running a single process in every container. You shouldn't have SSH on there. You shouldn't have these types of extra things. You shouldn't be trying to run a shell on there. You shouldn't be accessing them in that manner. So it should be a single process. That's the design goal. There are changes that have to be made to get there. But that is the design goal.
But it also uses SE Linux as the part of the container facility.
SE Linux is a separate concern. You could use SE Linux or AppArmor type systems. You don't have to though. Dan Walsh, I'll have a slide on here a little bit later. He has some good videos. I have it in the resources as well about SE Linux. But you don't have to use SE Linux. Okay, so let's make an image. What you'll need if you want to build an image is a Docker file, some context. Don't build at your root file system because it passes everything from where the Docker file is and beyond into the Docker daemon. So if you pass your entire root file system and that you didn't have enough space to do that, it would just run out and you'd crash. You can use a Docker ignore file to prevent that, but it's just best practice to make a directory specifically for each Docker file. The very first line is generally a from, which is your base image. So right now I have a base image out there on the registry, the Docker registry I run. that has our Cerner repos on it, and it's a rel 6 image or 7 image that came straight from Red Hat. And then there'll be a bunch of code for whatever you're installing, and then a command or an entry point. Entry point is relatively new over the last couple of months. It's preferred that you use an entry point. You will see that I'm still using a command because I have not changed our image yet. But it's preferred that you use an entry point and a default command. And you can override that command on run. But the entry point should be specified, and it'll be basically just a shell script that gets executed with whatever command you put in. And then the end result is an image, not a container. That's a very important distinction. You'll see a lot of people reference containers and images as being the same, but they have different commands associated with them. Basically, an image is like a class in object-oriented programming, and a container is a running instance. So you have one class, as many instances as you want. And then the Docker daemon builds the image with the context that I talked about. And this is one of the things that CoreOS has complained about, and that's why they started a completely separate containerization system. I don't see this as being a problem. I see hosts as being ephemeral. So if the Docker daemon fails, you just start up a new system. You don't need, unless some people have the idea that they're going to run thousands of containers on a single node, and then their daemon crashes and they don't have a way to fail back somewhere else on another virtual machine or something. So I would not count on the daemon or any system to live, honestly.
You can tell me if this is on a later slide, but this is kind of similar to, strikes me as similar to outburst conversations we've had in the past. Like, for example, doing a lot of research. One of the things that we always got tripped up on was licensing. So would you say that we've sort of taken the approach, this has been an internal Cerner cloud conversation? Because I don't think you can necessarily take an image with a bunch of technology in it, for example, and ship that to UPMC without being illegal. Does licensing come up in the discussion a little bit?
I would say that depends on what it is. So I think like if you were on, say your OS, so is licensing a concern for Docker images? If you were on an OS that, say, is Windows, and they want you to purchase every Windows you have, then every Docker image would have to be licensed with that Windows.
Yeah, I'm not necessarily on the point of should we license it or not. I'm pretty sure we should. I'm on the point that you can't necessarily legally ship that image from Cerner to an external entity. So this seems like it becomes kind of a cloud conversation.
That depends on what it is, I guess, but if you're shipping it now, then you could ship it then. I don't know what you'd be installing.
Because of that limitation.
Oh, okay. Yeah.
It has the same limitations of
Right.
licensing that any other product.
Right, this wouldn't be any different. Like, and I think that like if we're running rel on rel, their licensing is not based on how many instances of rel you're running. So you can run as many as you want. Now Windows, we actually have some Jenkins instances that run Windows that we have not figured out what to do with them yet because
I just want to make sure if there wasn't
of that.
something special.
No. It's just
It does not solve licensing.
right.
And my point more, Kevin, is we don't want to go around telling everybody in IP, this is how we're going to ship all Millennium to all clients in the future, right? Because
I
it's illegal.
I would expect all the Docker stuff that we do for the foreseeable future to exist only in our product
Okay.
and not be in most
I got a quick question around, so back to kind of the conversation I was saying earlier about how we have different versioning, and the one your master container had the newest one, it can still communicate between the different, what I call those images. Now, from like a security standpoint, if you just say like, at this particular image has a particular exploit, but your overall container, let's just say, is protected against that particular exploit, does that also protect the images, or do you still have to update the images themselves?
So as far as keeping essentially the base OS updated for your container is what you're asking. So if the container, if there's a, say this, what Ghost that just came out, and we need to update all of our systems to match this. If you update the host, it's not going to update the issue, whichever it is, SSL or Ghost stuff. What we do is this requires a different way of thinking about everything. This is part of that fundamental change where we automate that kind of stuff. So whoever's managing that base image will push out an updated version, and then that will trigger builds of all of these containers, and our system should go through and validate and dev that this is working, that this change is working, and everybody will get the update automatically. And then at the point of deployment, we can make the decision whether or not we want to deploy. So I just kind of envision like all of these containers just being built and put into the registry so that we can deploy them when we want to. We could make it so we deploy them automatically, but I don't know that that's going to fly.
But initially, you're saying you could have image 1 and image 2 with different components. The containers running could be based on either one of those over time.
Yeah. The host could be anything, and the containers would just be based off whatever that base image is. However, you could change the base image to be RHEL 7 all of a sudden, and then you'll put that out as a new version. Okay, so that's a joke. I had made a movie and I recorded it at a very small resolution for the text. So I realized yesterday that was not going to fly. So that's why we're using a Mac today. So I will go ahead and run some commands. So first, can everybody see this? So this is, I'm running boot to Docker on Mac. And if you see, this is Docker help. So there's a ton of commands that you can run. This used to be much, much smaller, like maybe 10 commands when I first started. And then if you want to see the version, then you can just type in Docker version, and you get all the different versions there for the client and the server. You can do a Docker info and see what driver you're using, which we're using the storage driver AUFS. On the other node, we're going to be using Device Mapper. Device Mapper actually had some issues for a while, where basically it has a data file that can be by default 100 gigabytes, and there was a flaw where it would allocate the amount of space it needed for an image layer, and then it would never go away. So I kept hitting a lot of limits. Now that just got fixed in the latest release. It wasn't supposed to be out until I think RHEL 7.1, but the RHEL 6.6 has it now. So from my testing, it seems to be fixed. So I don't know if that'll change, but they are moving to an overlay file system, which is, I think, just released in 1.4, but it's really pre-production beta type stuff. And we can do, let's switch over to the base directory. We will build this. It's already built, so it's actually going to use a cache, I hope. Which you'll, no, maybe it's not. Oh, you know what? It's because I'm using the wrong image. So I have a version on here that will also do the Java version. So you get it default with the proper variable set. Let's see what images I have. So that failed run actually created an image right there, and there's no name or anything on it. But we will go ahead and build it again. Now what this is doing is this is sending all the context from that base directory and sending it to the daemon. It's using the cache for all these because I've already built it, which is really nice if you want to save some time and you just want to change something at the end, but that's also part of that image layering. So if we go ahead and go over to the supervisor, and we build this one, this one just has just some ports you can see here. It's also from Storm Base latest, which is the one I just made. And then it's got the command right there. So it should start the supervisor when it runs. And we'll look at these again. So when I built that, I didn't tag the image. It's currently tagged right here is 1.7 because I built it earlier. But we can also do this command, which did not work. This command just allows you to tag it. So we went ahead and we tagged it with the latest. That's the kind of system that would allow you to get the latest RHEL version or something. So if you get a security update, you can just force a pull with docker build -- pull, which is something new out in 1.4. We can actually look at the history of this image, and it will show you all the commands that were used to build each layer. If you want to see more information, which might not show up well on here, you can use this -- no trunk, which will give you even more information. The entire command will be there. And notice that I'm using yum clean all. This actually saves quite a bit of space. Previously, I believe it was 826 megs, and it saves about 50 every time you do that. So we will push the image to the registry so that we can access it from our host systems with a Docker push, and then everything's already pushed, so it just goes ahead and no ops on all those. But my Docker registry is this mplus.docker.hacks, which is just a local internal registry. And the image name is Storm Supervisor. And then the tag is this 1.7. The tag can be anything you want, but probably go with semantic versioning or latest is a common practice to get the latest updates. And we will go over to the other system that is currently running this container. We'll do a Docker ps-a will list all of your containers, whether they're running or not. If you just want to see what's running, then you can just do a Docker ps. And right now we have this one running, which is the 1.7 version that I created earlier and went ahead and ran on here. And we can do a Docker exec. When you do a Docker exec, that actually executes whatever command you want on the image. You can use that tag, or you can use the name, which is this mesos with a bunch of hash numbers behind it. And then you can do something like ls-al, and that'll list everything inside the containers file system. So you can, later we'll check the Java versions on these. And if you want to see even more information about this, you can do a Docker inspect. And this will list basically all of the details about this container. You'll see your environment variables. This has AppArmor type information. It shows the arguments you provided. Just a whole host of information, your CPU shares, your memory allocation, which is the C group type information. And we will, this is all running with Mesos and Marathon. So here is the what I used to get this started, and we can actually see it on Marathon here, and it has a bunch of previous configurations. So I've gone through and ran a bunch of different versions of this. And it will do a rolling upgrade. So you can set it to roll an upgrade over time, which is really the benefit of Docker because these things spin up almost instantly. And if it fails, it's not running an entire chef run again to restore your old state. You just restore your old state. It's really simple. And then this is the.
Is everyone here familiar with Chef?
Sorry, I assumed.
Yeah.
Sorry. We use it a lot. And this is the Mesos, these types of technologies that we'll be getting introduced to work with things like Docker. And it shows you, it's basically, they describe it as an OS for your data center. It describes your CPU allocations, your memory. It'll show your active tasks. You can view logs and things from here. And then the containers that I have running right now are available right here. So one's running on this 12 node and one's running on the 10 node. So let me exit this. So we don't have to start it with Mesos and Marathon. We can do a run like this, which is about what the command looks like. So the -C tells us how many CPUs we want. The -M is how much memory. You have to specify an M here or G or whatever. It has to be, I think it's got to be at least 4 megabytes. And then an interesting thing I noticed was that the container uses the CPU clock, but it does not know about local time. So it uses the local time of wherever you created it. So usually we'll mount in local time and actually time zone, which was not on this node, so I didn't mount it in. But that's what we do for our Jenkins instances and everything, so that we don't have an issue of, logs suddenly being off an hour for no reason. And then we'll name it local, and we will run the same image we're already running. And then you see it right here at the top. It looks a little different. It has this right here, which is because it's on a bridge instead of host. These other containers that were started by Mesos are using the host networking, and this is using the bridge, which is Docker 0. So Docker sets up its own little bridge internally to the host, which allows you to say these are exposed, but they are not published. So you can't just go on there and access 6,700 and 8,000. You have to actually publish those with the -P option, and then you can publish them to a host port. But we didn't do that, so what we'll see here, hopefully, is this. It's referencing the host name, which is just the container ID. So that could cause some, so that could cause some confusion, and that's something we need to work out if we're going to be doing that type of setup. How to identify these containers that are relatively ephemeral and may not be there when you go to look for them. So we have this image running, and we can see it by referencing its name as well. Earlier I referenced the image ID, and you can see these ports are here. They are not linked to anything. And then the network mode is bridge, which is the Docker 0. And you can see that it doesn't have as many environment variables because it wasn't started by Mesos, so Mesos didn't reference a bunch of things on it. And we can run it in different ways. Let me go ahead and stop this one. Oops. I apparently copied something. Right. So I can stop it by its name, and it will still exist there until you do a remove on it, an RM. But we can actually put in a command, a --RM when we run it, and when you do that, it will automatically remove itself. Now, I've started up a bash inside of this container, so I can install whatever I want. Right now I'm running as root, so I could do a yum install something. I won't do it because it takes a while, but you can do whatever you want. You can do this, and we can see that we're in the storm by, if I got it right, by seeing that we have the stuff we installed earlier right there. And then when you exit, it'll take just a moment because it's removing it. And when you do a PSA, it won't be there. It would have been on the top if it wasn't removed. So that's the basics of making an image. There's a ton of options out there, and honestly, there's so many that come up that are different than what they were in the previous version. Sometimes they make breaking changes, but it's really something you have to look at the docs for these types of things.
It's not the intent for you to interact with a container from an installation perspective. You're supposed to put that all in the Docker file, is that correct?
Right. Everything you want your in-state container to do should be in the Docker file, with the exception of configuration, which is often things are protected and you can't put them in GitHub or something. So you want those things presented at runtime. Or if you want to, there's a concept of a data container, and that data container could have a bunch of other information. I actually have the registry. You can see right here. This UI is running in a container. My registry here, and this is just a list of images, is running in a container. And all of these images are linked to with a volumes from command on the run command, or volumes from attribute on the run command, that attaches this data container and then uses whatever volumes it has, which that data container, I have referenced a volume that stores everything on the host. So I can spin the data container up and the registry up as many times as I want, and all the data is there. So a lot of times when you restart the system, your containers don't start up properly and you have to go back in and start them. And a couple weeks ago I thought I lost everything, all of our images, but I didn't realize I was apparently smart and did it the right way. So I was able to restore everything really quickly. And I mean, all of these images were saved, which saved a lot of us time in re-uploading them. But yeah, that's kind of the idea around Docker, is that everything is in the Docker file, but you may need things like data. But your Docker containers, the actual app, should be ephemeral and should not contain state or anything like that. So
That's the huge change over what we're doing today. Whereas today we run Chef, which is automating tons and tons of commands on every node. We have lots of state on all of our nodes, so we have to, in order to support Docker, we have to change the way your application is written or deployed.
right, yeah. I mean, this causes some fundamental changes around what we do now. And everybody is coming under this, because a lot of people didn't have microservices or that type of architecture. So I mean, it requires a different way of thinking about apps and how you interact with them, how you deploy them, what they are in some instances. It's pretty cool stuff. So, so moving them around, we are setting up a private registry. Fingers crossed it's not done yet, so hopefully that happens. And then that should allow us to upload it to a registry that we can then deploy to all of our environments, the exact same image. So its state will be persistent from when you, or its contents will be persistent from dev, where you tested everything, all the way up to prod. And maybe Docker Hub Enterprise at some point. The registry is not perfect. So Docker Hub Enterprise should be out next month, I think, for beta, pre-release type stuff. But hopefully that will provide authentication, which is not available yet in the Docker registry. Should be available soon, though. I think next month authentication should be in. But Docker Hub Enterprise will be, the Chef Enterprise type system, and hopefully it can house like authentication tokens and all that kind of stuff that you need that's confidential. And then, of course, we'll just provide that config from whatever resource we can. It could be Zookeeper. It could be deployed by Chef, as we do a lot of stuff with Chef now. We can deploy those keys and everything we want at the time we do the Docker container deployment. We can provide those environment variables. So there was an instance where we found that inconsistency with Java, where we thought that Chef was managing our apps to have a particular Java version, but then when we went and looked at all the nodes, they were all different. So they were not getting, somebody was installing something separately, or something was happening where these Java versions were not the same in some of our dev clusters. So usually when you want to upgrade Java, you have to upgrade everything on the system, or you have to go through the pain of referencing it, explicitly to a Java install, which can get a little hairy, especially with this type of thinking where everything's a microservice and it can be installed on anything you want, on any system you want. So we will go ahead and we will upgrade our Java version on the image we just made. We'll go ahead and go into the base. We'll have to change our Docker file, our base Docker file, because it was referencing the 7U67, and we want it to reference the 8U25. I guess I can also note that usually there's a maintainer command, so that when you go through that history that I printed out earlier, there's a bunch of maintainers listed there. That way you can yell at somebody who put something in they weren't supposed to. And then here we just go ahead and we go through yum install, and we install Storm, and then we install a couple of RPMs here at the end for all of the dependencies of Storm. And then we only run one process. So we actually have do an ls, you'll see we have a Nimbus and a supervisor. We'll also have a UI. So all of these will be separate containers that come with their default command. And we'll go ahead and run the Docker build. And this time we'll tag it when we run it. And we'll tag it with a 1.8 version. And that's already in my cache too, so it built pretty fast. I didn't realize that Docker was so smart, because I deleted the images and assumed that they were all gone. So it didn't actually install anything new. We will go ahead and we will tag this with a latest tag as well, because we want everybody to get our awesome new Java 8 so that we can get rid of our heap or whatever. So it actually, at the end of here, it will tell you that it built, if I can find my pointer on here, that it built this image ID right here. And you can add that in right there. And I have to use this -f tag because I already have a Storm base latest, and it defaults to not allowing me to just override that. We'll look at our images and see that we have the same image ID for both our latest and our 1.8. And it's a little bit bigger because Java 8's bigger, because everything gets bigger. And now we can move over to the supervisor, and we want to build it on top of this new base image. So We'll go over to the supervisor and we'll look at the Docker file. I have this one set up to automatically get the latest. So if you have the latest on your system, it'll automatically get it. You can also put a -- pull on the build command to force it to go to the registry and pull the latest, which is what we would want to do for forcing critical updates. So I don't have to update that, but I do need to run this command with the -t as the 1.8. So that one actually ran all of the commands without the cache. Why, I don't know, because I thought I deleted that one the same way I deleted the other one. And then that one built that image. So we can use the name for this and look at the history and see all of the different layers and where they came from to include this base one, which is 140. That's a rel 7 image. The rel 6 is bigger. And then you can see that you had, you got something from this repo, which is 325 megabytes. You did another yum update and yum install. So you can see what's taking up all of the space on each one. You can optimize for that because you don't want to send, a gig across your network every time you do an upgrade or something. So we'll go ahead and push this to the registry and hope it's not full. So this is actually pushing right now because it wasn't in the registry. However, all of those other layers were already in the registry. So that saves a lot of time and space because the same thing will happen when you go to pull these onto your host. All right, so that is in the registry. And now we can come over here and we'll do a Docker pull. And we'll see it start pulling down. Now, if we were to launch this with Mesos, it would do the pull automatically if it wasn't on the host. But you can see if we were sending, large files over the net, or Chef has an option to create a diff on top. So if you upgraded your Java version, you would send the entire Java version and everything else along with it.
So if you consumed another Docker image from another open source project, submitted it to the registry, made a dependency here, you went to another solution,
Okay.
and you basically needed the same thing because it's in the registry, and they built against it, they would be able to consume it.
Right. So you're saying if this got pushed out and now it's updated and they want to update theirs, yeah, they just build against that, the latest tag or whatever it happens to be, and they'll get whatever you've changed will come out.
And then when I go through my stages, my life cycle for my code, all the way to production, production just does a pull because it's already
Right. Yep. Production you should never be, with Docker, you should never be building in production. You shouldn't build on that host. Your idea should be that whatever you build in dev is what you test in dev, and then that gets pushed to the registry, and that's permanent. You shouldn't be, right, you shouldn't remove it or anything, similar to our, the repos and stuff. So, all right, so we have this, and we're going to update this current app that we have running because we want to put out Java 8 on everything. So conveniently, these were named 1.7 and 1.8. I just realized that. It's only because I messed up the other day. So we'll go ahead and save that. And I will show you the curl command we use. It just sends this over. And then Docker PSA will still show that this was shut down. And there it is. So 1.8 has started here. And we can do let's actually look exec after. Now we have the newest 1.8 version. It's still deploying because it's pulling on the box 10. I only pulled this on 12. So it will have to pull down that image on the box 10, and then it will start it up. And we can go over here and we can see that we now have 2 on 12, and it's still waiting, of course, on 10. And then they're all here on Mesos as 3 instances running. So let's say we don't want to get rid of this Java 7 version. We want to test and see if Java 8 has any issues in prod. So we want to run both of them at the same time. So we can go ahead and edit that file again to have a different name. So instead of storm, we'll do a storm test. And we will go ahead and run the 1.7 version. Now our plan is to have Java 7 and Java 8 running on the same host. All right, so that one's fully deployed. We can go ahead and run this again. And it is now storm test. We can go over here. We can see that it is now beginning to deploy storm test, and it's deployed already. We can look here and see that, in fact, we have a 1.7 and a 1.8, both running at the same time, and we can verify the Docker exec and then the image ID. That's running 1.7. And that's running 1.8, both on the same host, and we can test both of them at the same time and see if the same data creates the same issues. As you know, there's a lot of changes in 8, so there might be. And if we come over here, we can see that, in fact, we have all 4 of them up running now.
So when you're doing those updates and pushing them that way, it doesn't actually get rid of the version 7. It just makes the version 8 running and keeps it until you run a clear on the other version.
Right. If you're running them that way with 2 separate apps, it'll keep both versions. If I deployed the same app, say I deployed the 1.8 version like I did, because it was running 1.7 before, I deployed 1.8, and it did a restart on that. So it made sure that it shut it down and started up the new one. If the new one didn't start, which I actually, during testing, I had an issue with it, it just went ahead and found another spot for it to start. So it can also have health checks, all kinds of things. That's not necessarily Docker specific.
So I guess I'm looking at it from like a licensing perspective of what we got to pay, and say like from money, and you got to have your WAS and all that installed. And say we go to the newest version, which has certain ones like your virtual centers added in. Would, say when we're scanning that, would that come up with 2 different instances saying I have one at this version and another one still found on this image at this version as well, or does it actually remove it from the registry when it's actually loading that whole new app with the update?
So in the registry, pretty much everything stays, kind of like repos and stuff. So everything, basically asking if a newer version will remove it from the registry. Everything's tagged and all of the images are layered, so they're all different. So everything will stay there. However, a container is different. So if you started a container on a node and you wanted to know, for licensing purposes, what am I actually running? You would have to see which versions of your container, of your image, you are running as containers on each node.
So if you're trying to load balance and you're pushing an update, will they load balance still accurately, even though like one may be in the process of updating while the other container is still at the other one?
That's more system dependent, orchestration system dependent. With Mesos and Marathon, you can make it so that they will load balance appropriately and start up have the right number of containers running. Marathon does that by constantly checking to make sure that its containers are running. There's different technologies like Kubernetes that allows that type of load balancing, and in fact spins up pods, which are groups of Docker containers, as they can't find, like if Kubernetes can't find them, it just goes ahead and spins up a new one. And if you're talking about licensing and running multiples at a time, that could be a concern, but you can set those parameters in that type of system. Yeah, that was another joke, but I didn't have the video. If anybody wants to laugh at it, feel free. So one of the goals, at least for me with Docker and things like Storm and Jenkins, is to be able to run more efficiently, so that I can specify the number of CPUs I want a particular app process to run with. It doesn't have to be whole numbers. I run, like my chef cookbooks that I build, they are all run on like 0.1 or something, so they don't need a whole lot of processing power. You can also allocate the exact amount of memory you want, which is really useful because builds can kill other builds and things like Jenkins, or we actually had issues with Storm where the Docker container was too small by default, and I hadn't realized that you could specify the memory that you would need to, and so the executors would kill the supervisor and just leave a stale container sitting out there, which isn't very useful. So you can manage that, and that way you don't have your Storm supervisors killing other Storm supervisors. And we've had issues where logs fill up var and then kill your system. You can specify how much hard space it gets, hard disk space it gets. You should also use a logging container. So like put Splunk folder in a container and port all of your logs to that. These functions are managed with C groups. So yes, C groups just got simplified, so you don't have to manage all that state. Docker handles that kind of stuff for you, and with an orchestration system, hopefully you're just specifying that in a YAML or TOML file.
Have you found that, you mentioned Splunk and some others, have you found that there's pretty good third-party technology support already for this, or anybody calling out, we don't support this?
So as far as support from third parties, I'll talk a little bit more on that, about Docker Hub and public libraries and things like that, and what we should do or shouldn't do. I haven't seen much on Splunk specifically supporting it or not supporting it, so I'm not sure what they're...
You think it's a little hit and miss today? You're just trying some things, obviously, but at some point we probably want to know whether they officially support it for production, right?
Right, I assume that a lot of these technologies would be similar without Docker. So we shouldn't necessarily look at Docker as something fundamentally different. As far as the process inside, it's just a different way of running the process.
Okay. Do we know?
Yeah, a different deployment model. A lot of these things change around it, but the process is still the same.
Do we think we can have a longer conversation on it, but do we think that those third parties agree with that position? I think it has no impact?
We don't know.
Yeah,
We don't know.
I have a quick question for you too, just because it was on that topic. How long do you expect or envision the containers to live? Or do they kind of vary? Some live seconds, others live days, months?
Right, so I think it varies. I think that containers should be looked at as ephemeral and that they should be relatively short-lived. However, you could have things that, I mean, really they should always be short-lived. You shouldn't maintain a whole ton of state inside of it. So now that's relative, so they could last a week, and then when you deploy the new version, you're obviously starting up a different container. You could run things like processes for HBase and Hadoop and MapReduce stuff, which could be much shorter. Yeah, I mean, they're offering services on some of these clouds that don't last seconds. So you'll have something that just happens and that's it. It's incredibly ephemeral and not really, doesn't really need state. That's kind of the goal with a lot of these. What's that?
You do a Google search.
Right.
Spawn off hundreds or potentially thousands of containers across your environment, and then as soon as it responds back to you, they're gone.
Yep, they all just die. Yep. Okay, so let's look under the hood a little bit. I don't have a whole lot of time, so I probably won't be able to get to a lot of the security stuff since we're about done. So I just say this maybe in closing, and the rest of the security stuff you can check out Dan Walsh for SE Linux. He also has a good blog post. or I'm sorry, not a blog post, a YouTube, and that containers do not contain. So we should really look into the security of containers and not treat them as a VM or something. At this point, I would say we should run them on VMs instead of bare metal, especially anything internet facing. You could probably run things like Hadoop on bare metal. You'd probably want to, but you shouldn't treat these as something that is necessarily secure. These are really better looked at as any other technology that you need to go ahead and put in some extra legwork to make them secure. So probably have to go ahead and finish up. I had some more about securing Docker. They use capabilities. Don't run your Docker containers as root, because that's like running root on your host. Don't use -- privileged, because that gives you all of the caps, capabilities, so that you can do pretty much whatever you want. And namespaces. The networking is an issue. It's been an issue for a while with Docker. They've made some improvements. They now have more options, and there's a lot of things like using an ambassador container on a host that will go ahead and coordinate with other hosts, with other ambassadors on other hosts to get that networking, so that your app can communicate with other apps that are behind that Docker Zero bridge. And don't run things from Docker Hub on your systems unless they're well vetted. It's a similar problem with Chef, where you go and you just run stuff that's out there in the public on your systems. I mean, of course, we look at all of the little code and every update, but with this type of thing, it's better that you take what they have, assuming that you are allowed to, and put it into your own Docker file with your own base image, because your base image will be copied everywhere. So you really just want one base image for an enterprise like this, that you transfer once to a host, and you don't transfer it again with all of your other images. You don't want Ubuntu and Debian and all these other crazy things that you would then have to rely on them updating for Ghost, which they probably won't in the amount of time you want. So I only use trusted code, but I wouldn't run anything that's not based on our base image at Cerner, as far as something that's actually going to go to prod. It's just really not feasible. And yeah, so build our base image, and eventually we'll have a single instance of our Docker Hub or Docker registry, so that everybody has access to all of the images. And these are some resources. We'll post this out so you can take a look at some of these. I have my blog post on Docker containers versus images. Containers do not equal images. I thought it was important enough, so I wrote something about it. And any questions? If you have questions and you are watching over the internet, you can ask them in the Q&A section. We have nothing in production at this point for Docker. There's ideas around there of what we want to move to production, but we don't have any official plans or anything yet. The only thing we really have running Docker at this point is my Jenkins. So, and that's really been helpful, because Jenkins can put quite a bit of demand on systems with some of the builds we have. So it's really helped flesh out some of these issues. Any more questions, or is everybody ready to go home? Yeah, definitely.